Last type of graph are the inverse tangents or the arctangents. So, same as with regular tangent, we start with the asymptotes. So, I'm going to have horizontal asymptotes at negative pi halves and at positive pi halves. Same as in the past, if it helps to rewrite this, x will equal the tangent of y. So this is our angle. So if you want to make a table for tangent, it's pretty straightforward. I can do a negative pi fourths, 0, and pi fourths. The tangent of negative pi fourths is a negative 1. The tangent of 0 is 0. And the tangent of pi fourths is positive 1. And we have these asymptotes as our guidelines. And so, again, this is not, just like with regular tangent graph, this is not an inflection point. We do not come down, and this is gradual. It does go up at about a 45. There's nothing special or fancy that happens here. It just increases. And so there is our inverse tangent graph. So for this kind, I am going to demonstrate a vertical shift. So now notice this is not in the parentheses. If this was in the parentheses, it would be a horizontal shift. It's not a horizontal shift, it's a vertical shift. So the graph is going to move down 1, okay? Well, that causes some issues because this is in radians. So if I want to move my graph down 1, I have to move down 1 unit. Well, that makes things really confusing because this is in terms of pi. So my domain is going to still be the same. So my domain for this graph is going to go from negative infinity to positive infinity. My range, and because this is in terms of pi and this is not, I'm just going to take this and I'm going to say negative pi halves minus 1 and positive pi halves minus 1. So what's going to happen for my asymptotes if we take negative pi halves minus 1, it's about a negative 2.5. Well, because we're doing it on here, this is a negative 3 pi fourths. So if I take a negative 3 pi fourths, it's going to be a little bit lower than that line because this pi is 3.14, okay, down here. This is 3.14, so on and so forth. So this is going to be about right here. So if we look at one block and a little bit more, so same's going to happen up here. And you can certainly do the math for this, and I'll show you in a second. But if we check, if I take pi halves minus 1, it's going to be about 0.57. Pi fourths is about 0.78, so it's a little bit less than that, okay? Now, as far as my points are concerned, everything is shifting down 1. So if I stick with that, even if I don't take the time to make, everything went down a block and a little bit more. So if I was at 1 and I go down a block and a little bit more, I have that point. This was at 0. If I go down a block and a little bit more, I'm about right here. And same with this one. If I go down I go down a block and a little bit more. Now, where can I go from here? This would be a good graph to put on the calculator to double check those points. Now again, the problem is everything here I've got written in radians, and this is not and the calculator's not going to give me radians. But I can take a quick peek at my graph. So I'm going to do the inverse tangent of x. Now this is not in the parentheses, so then I have to do -1. And I'm going to go to zoom standard just because this is back on 1, 2, 3. If I wanted to, under my window, I could change my y-axis, and I'll show you in a second. But you can see what this is going to look like. It's going to come down here, come up here, and that's right. Now, so that my graph matches this, I'm going to go under my window. On my y-axis, I'm going to go from negative pi, oops, wrong end, negative pi to positive pi. And then that way my window is going to go from here to here. And then this goes by pi fourths, so my scale I'm going to make pi fourths. There is no quick, easy way to do this on the calculator. The zoom trig will change your x scale to radians. There is no quick way to change your y scale to radians. So if I take a look at my graph, you can see that this is pi fourths right here. And so it's happening a little bit below that. If you wanted to, I could graph the line pi halves -1. That's going to be my asymptote here. And I can do a negative pi halves -1. And you can see, notice that's just below this line here. That's just below this line here. And so if you wanted to, you could go through and find the x-intercept. An x-intercept is an important piece. I can see quickly that it's going to happen right to the left of 2. And if I look at x equals 2, I can see it's just above the x-axis.